Hello, Breakout Honor students. Mrs. Myers here. Today we are going to begin a new section of our chapter. It is section 6, and it is all about solving a system using what's known as a matrix equation and the inverse of that. Okay, so we're going to start off with a system that is a very, very easy system to solve using other known methods. It's a 2 by 2 system, so 3x plus 4y is equal to negative 2, and 5x plus 3y is equal to 4. Okay, so again, this is something that you certainly would know how to solve algebraically, just using, the elimination method, for example, or very easy to solve using Gaussian-Jordan elimination with an augmented matrix. But now I'm just going to show you a new solution. And I'm starting with a very small matrix, only a 2 by 2, because I want to be able to show you how to do all the work by hand, and I don't want it to take us absolutely forever. So here we go, a matrix equation. Okay, so there's 3 different matrices that you need in a matrix equation. The first is the coefficient matrix, and it kind of speaks for itself. It's just a matrix that uses the coefficients. Okay, let's take note of the size. That is a 2 by 2 matrix, okay? 2 rows, 2 columns. So what we're going to do is we're going to multiply that by the variable matrix. And again, that speaks for itself because it's a matrix that has only the variables in it that are in the equation, so x and y. And let's take note of this size as well, which is a 2 by 1 matrix. And what we do is we set that equal to the constant matrix. And again, that speaks for itself because you are using the constants that the equation is, each equation is set equal to. Okay, and let's take note of that size. That is a 2 by 1. So first thing we want to do is we want to relate what we did in the previous section with matrix multiplication with this matrix equation. So if you want to multiply 2 matrices together, okay, what needs to be true is that these inner dimensions must match, right? The number of columns of the first matrix has to be the same as the number of rows of the second matrix, which is true. And then the size of the product matrix is the number of rows of the first matrix and the number of columns of the second matrix. So the product matrix is going to be a 2 by 1 matrix. Now, let's note what this is set equal to. This is set equal to a 2 by 1 matrix. So again, back from that previous section, if you remember, matrix equality is such that the dimensions of the matrices that are set equal to each other must be exactly the same, and that's what we've got here. 2 by 1 equal to a 2 by 1. Now, let's relate this system to this matrix equation. So how do we do multiplication of matrices, right? Is we use row 1 by column 1 to get the entry of row 1, column 1 that we're being set equal to. So if we do 3 times x, right, and then we add it to 4 times y, okay, that's how we do that matrix multiplication. We would set it equal to negative 2. Well, that's exactly what the first equation says, right? And then when we do row 2 times column 1, we get the entry of row 2, column 1 here. And again, how you do matrix multiplication, right, is you have 5 times the x, and then you would add to it the product of the 3 times the y, and then that would equal the 4. Well, there you go. That's exactly what that equation says. Okay, so hopefully you kind of see the relationship there. So anyways, what we're going to do in order to find the solution to this system using a matrix equation is we're going to multiply by the inverse of the coefficient matrix, the multiplicative inverse of this, okay? Now you know this by just what you always do with solving an equation, right? If I give you 5/3 x is equal to, I forgot my x, is equal to 20, and I ask you to solve this equation, okay, what you're going to do is you're going to multiply both sides by 3/5, right? And that product is going to be 1x, okay? And of course, this multiplication is going to be just 12 here, right, when you reduce that out. And then what do we know about 1x? We know it's equal to just x, and now we have our solution, right? So what this is called that you just multiplied both sides by is this is called the multiplicative inverse of the coefficient of the variable, right? Well, we're going to do that, but with the coefficient matrix, whereas this is with the coefficient, okay? This is the coefficient matrix, okay? So off to the side here, okay, we are going to find the inverse of the coefficient matrix, okay? And how we do this is we set up a doubly augmented matrix, okay? So here's what this looks like, a doubly augmented matrix. Now there's my dot, dot, dot for like the augmented matrix. You're used to seeing that dot, dot, dot already, okay? So on the left-hand side, what we do is we have the coefficient matrix, okay? So that would be the 3, 4, 5, 3. And then what we do over here is we set up what we call the identity matrix. Okay, so the identity matrix is when you have that diagonal of 1s and everywhere above and below the diagonal is 0s. So very, very easy for a 2 by 2 matrix. It's just the 1, 0, 0, 1. Okay, and then what you're going to do is you're going to perform a series of row operations that transforms the coefficient matrix into the identity matrix. And as that's happening, the identity matrix is changing, and what it will be changing into is the inverse matrix, okay? So let's get started. We're going to get this entry to become a 0. Okay, so to get that to become a 0, for example, I'll do -5 row 1 plus 3 row 2. And then, so we recopy the first row as is. Oops, that is a very sloppy 0. Okay, and now let's do this. So we've got -15 plus 15, there's my 0. We get -20 plus 9, there's my -11. We got -5 plus 0, there's -5. And we got 0 plus 3, so there's 3. Okay, now we're going to take this and we're going to get this to become a 0. And that means we're going to recopy that second row as is. And in order to get this to become a 0, we're going to do 11 row 1 plus 4 row 2. So that's going to be 33 plus 0. Okay, that's going to be 44 and -44, so there's a 0. So it's going to be 11 and -20, and there is my -9. And then it's going to be 0 plus 12, so there's the 12. All right, so now we're going to get these locations right there to become 1s. And we are going to do row 1 divided by 33 and row 2 divided by -11. So now we've got 1, 0, right? And -9 over 33. So we're just going to reduce this, okay? And that's going to reduce down to -3 over 11. And we have 12 over 33, and that's going to reduce down to 4 over 11, okay? Now we're going to take this row and divide it by -11, so that stays 0, that becomes a 1. So now that is just +5 over 11, and this is -3 over 11. Okay, so this has now been transformed to the identity matrix, and while doing that, we have changed what was the identity matrix into the inverse matrix. Okay, now here is how we can do a check for this, okay, to see that we did all this work correct, is we are going to multiply the coefficient matrix by what we believe to be our inverse matrix. Okay. And think about it back here, right? What happens when you multiply your coefficient by its inverse is you get the identity number, which is a value of 1, right? And why is that so important here is because 1 times anything is always itself. So we're going to prove that this multiplies together. The coefficient matrix by its inverse should multiply together to be the identity matrix, which is right here. So I'm going to show out all the calculations, right? So we're going to do row 1 times column 1. So that is going to be 3 times -3 11ths plus 4 times 5 11ths. Okay. Then we're going to do row 1 times column 2. So it's going to be 3 times 4 11ths plus 4 times -3 11ths. Okay. Then we're going to do row 2 times column 1. So we're going to do 5 times -3 11ths plus 3 times 5 11ths. And then we're going to do row 2 times column 2 for this entry right here. So it's going to be 5 times 4 11ths plus 3 times -3 11ths. And now let's see what we get, right? So this is -9 11ths plus 20 11ths, so that's 11 11ths, so there's a 1. This is 12 11ths plus -12 11ths, so there's your 0. okay? And I've got negative 15/11 plus positive 15/11, so there's your 0. And I've got 20/11 plus negative 9/11, so it's 11/11, and there's your 1, okay? So that is very good stuff there. All right, so we're going to come back over here, and we're going to show that we're going to multiply, and I'll go off to the side here so I have enough room. Then we're going to take this inverse matrix, okay? So negative 3/11, 4/11, 5/11, and negative 3/11. And we're going to multiply it by the coefficient matrix. Of course, we still have our identity matrix. Now, here's where we got to be careful and with our work and realize why this has to happen, is we're not going to multiply the inverse matrix by the other side coming after the constant matrix, because if we do that, I just realized I put an S there, okay, because if we do that, then we're going to have a 2x1 matrix by a 2x2 matrix, and that can't happen. You can't do that matrix multiplication. So what you're going to do is you're going to rewrite it first. So here's your inverse matrix. Okay. Then times your coefficient matrix. Your constant matrix, okay? Now we can do this. Now we can do a 2x2 times a 2x1, and the product will be a 2x1. That's okay. All right, so the product of these two matrices, okay, as shown right down here, ready, okay, is the identity matrix. Okay, and then that's now being multiplied by this constant matrix, variable matrix, I apologize. And then what is the product of this going to be? This is going to be just the variable matrix, right? Because it's going to be 1x plus 0y, so that's just 1x. And then it's going to be 0x's plus 1y, and then there's just 1y, okay? So now over here, okay, this is going to be just a 2x1 matrix, but let's show the work, okay? So row 1, column 1 is negative 3/11 times the negative 2 plus 4/11 times the 4, okay? And then row 2, column 1, is going to be 5/11 times the negative 2 and negative 3/11 times the 4. So let's see what we get. All right, so we have here positive 6/11 and 16/11. So that's 22/11, so that's a 2. Okay, down here we've got negative 10/11 plus negative 12/11, which is negative 22/11, which is a negative 2. So now when we have all that said and done, look at what we have. We have a 2x1 matrix set equal to a 2x1 matrix, and what do we know about matrix equality is that corresponding cells are equal. So now we know x is 2 and y is negative 2, and ta-da, we have the solution to the system. Okay, so we're going to do this one more time, but with a larger matrix, larger system, I should say. So now we've got 4x minus y plus z is equal to negative 5. We've got 2x plus 2y plus 3z is equal to 10. We've got 5x minus 2y plus 6z is equal to 1. All right, so let's set up our matrix equation. So we have our coefficient matrix, so 4, negative 1, 1, 2, 2, 3, 5, negative 2, 6, okay, times our variable matrix, which is x, y, z, and that's set equal to our constant matrix, which is negative 5, 10, and 1. Okay, so what we want to do is we want to multiply both sides by the inverse of this coefficient matrix, but you can imagine that that's going to be a little bit of work, right? So here's what I'm going to show you how to do this on the graphing calculator. Okay, very, very easy. So first of all, turn it on, and we're going to go to matrix as I showed you before, and we're going to put in this coefficient matrix right here. So we go over to edit, and we enter in that it's a 3x3. So go ahead and just put your entries in. Remember, when you press enter, it moves along the row, and then when it's done with one row, it goes to the next row. All right, now while we're at it, let's go back to matrix, and we're also going to put in as matrix B the constant matrix right there. So that is a 3x1. All right. Okay, so now we're back on our home screen, okay? So pause the video if you're not done yet, okay? So you can catch up with the graphing calculator. All right, so what we're going to do is we're going to find out what is the inverse of this matrix, right? Well, think back to the other problem, okay, back there, okay, when I used 5/3, right? Well, how do we get 3/5 out of 5/3? Like what, what operation can we do on the graphing calculator to get this value from this value, okay? Well, hopefully we realize that when we have this is the multiplicative inverse of this, it's really just a fancy way of saying it's the reciprocal, right? If you take 5/3 and raise it to the power of -1, okay, you would get 3/5, right, which is its reciprocal. So that's exactly what's going to be going on with the graphing calculator, okay, that notation right there. So we're going to take this matrix by its name, okay, so we're going to choose matrix A by its name, and we're simply going to raise it to the power of -1, okay? So that is how we find the inverse of that matrix, okay? And when we press enter, though, notice we get a whole bunch of funky decimals going on here. Well, a lot of those decimals, okay, being that they're repeated decimals or terminating decimals, they're really fractions in disguise, okay? So we're just going to press math, and we're going to choose number 1. We're going to get that to become, there we go, an inverse matrix in terms of fractions. Very, very, very often we get all those yucky fractions there, okay? So now we are going to just use this, okay? I'll keep it all to the side here, and we're just going to show our work, okay? We're not going to not write down anything that's needed on the paper from the calculator. We're, of course, going to transfer information, okay? So we have now 18/55. I'm not going to call out all those numbers. You guys you can see what they are in the calculator on the screen here, or you've got your own calculator. You just copy them down. Okay, and then you bring down your coefficient matrix. And you multiply that by your variable matrix. Okay, now you have to always multiply, each side of the equation by the same thing, of course. But we're remembering that you can't do a 3/1 times a 3/3. You can do a 3/3 times a 3/1. So make sure you put that inverse matrix first. Okay, so I'm just going to recopy it again here. Okay, and that's going to be multiplied by the constant matrix. Okay, so there we go. All right. So now we are going to show that the product, okay, of this coefficient matrix and this inverse matrix is really the identity matrix. And watch, we can easily do this on the calculator. Okay, so here's our inverse matrix that we multiply by the original matrix, and that's, there you go, there's your identity. Okay, so we put that down. And that gets multiplied by our variable matrix. Okay. Now what we're going to do is we want to get this inverse matrix, we multiply by the constant matrix. So back up here on our home screen, we call up the original coefficient matrix, raise it to the power of -1, and we multiply it by, call up the, okay, using the names always of the matrix, and use your matrix B, okay, because that was your constant matrix, and then just see what you get, and there you go, -1 through 2. Okay. We're not done with our work now yet, okay, we're going to show what is the product of this identity matrix by this variable matrix, and that is that it's just the variable matrix. And finally, okay, when we have a 3/1 matrix that equal to 3/1 matrix, here's where we have matrix equality, and we can set the corresponding cells equal to each other, and we've got our solution. Okay, so hopefully you have understood what I've just shown you, and like what you've just learned about setting up a matrix equation and how to find an inverse. Okay, I hope all is well. Bye.